All right, everybody, welcome. Welcome to our Connecting Sensors, Sports, and AI session. I think this session is going to be, I would say, very, very visual, very interesting, definitely. So thanks for being here. Thanks for participating in sports and supporting us. So just quickly, we will have two more speakers today in this session, so we'll try to get everything very, very quickly. But I'd like to take this moment to point you at a repo on GitHub. This is the repository we created to simplify sensors and sports development. This session is about how to connect from these devices, from IoT, literally IoT devices that gather data on human body, on different types of sports equipment, and then get it into the cloud, and then process it in the machine learning models. So the first stepping stone for you guys should be the SensorKit GitHub link. It's open for any Windows or actually any developer that uses that wants to use our technology. And then you can also learn about features that we used and that are very specific to the Windows Creators Update in our SensorKit. And these features, without these features, it won't be possible to actually create a system that grabs the data from devices that are used by athletes, and you'll see that today. And then transmits it into what we call, a repository or a hub, and then uploads it into Azure and then processes it in Azure. So without all this technology, without the new sensor stack in Windows, this would not be possible, of course. And then also, I welcome you to watch the demo by John Shuchak and Steven Guggenheimer, their virtual keynote about sensors and sports. There is a little section there about what we've done. There's also a machine learning part that is available. But without further ado, I'd like to introduce an athlete who helped us a lot, who's on the US Olympic team. And I'd like to welcome Cyrus Hostetler here. So Cyrus is on the US Olympic team. And Cyrus, why wouldn't you tell our audience the story about how all this started, literally, from the beginning?
So I'm an Olympic javelin thrower. I've actually made two Olympic teams, London and Rio, in 2012 and 2016. And I figured none of you knew what a javelin was, so I made sure to bring one along. It's a long spear. I've thrown a personal best of 275 feet. But in order to win an Olympic medal, I have to be within the top 1% of my ability. That's just have potential to win an Olympic medal. And so what we do every single day is train. I'm a full-time athlete. This is what I do for a living. I throw a javelin for a living. And this includes not just throwing javelins every single day. This includes doing sprints, doing jumps, throwing weighted med balls, and lifting as well. And this is all to hopes to be a more explosive person in hopes that it translates into throwing a javelin far. But it's very hard to define and figure out how to throw this far. The one thing is this is not a baseball. This is not a singular object. I can't throw this end over end. It won't go far. I have to actually throw this very clean and through the point and fly it almost like a paper airplane so it soars. And it's very hard I can't use a radar gun with baseball in order to find release velocity, and it's very difficult to find 3D orientational space. And so what we've done in the past, actually, is we've had biomechanists at our federation at USA Track and Field, and they take multiple camera angles, and they break down the video footage of us throwing. The problem with this is it's very, very slow. We take a skeleton frame, and we track every single joint in the body, taking hours to track one single meet, where I get 6 throws, which may not have been a good day. And so months will go down, and finally I'll get a PDF document that says, oh, here's your release speed. Here's what angle you threw it at, and maybe some ideas of how I can do this better. But it's 9 months down the road. It's already too late. And I thought there must be a better way. And so I'm actually a tinkerer at home. I have a garage full of stuff. I build drones in my spare time. And I've got these little chips that are about this big that have accelerometers and gyroscopes. They recognize 3D orientation, acceleration forces, velocities. And I also build Bluetooth speakers. I was putting Bluetooth chips onto speakers so I could build something more powerful than things that were on the market. And I thought, there must be a way to combine these two to give me instantaneous data and Bluetooth it to my phone. And that's when I came with a small prototype, but it didn't give me much, really just some velocities. And that's when I actually ran into and met Kevin and Max with Microsoft. And they really helped develop it the rest of the way. And so what we have here actually is a modular device, very much improved from my Mark I, but something we're still working on. But it can give us my runway speed as I run down the runway before I throw, my release velocity, release angle. This is a 3D device, so it's not just release angle as I throw it this way, but it's also how it tilts this way and it's thrown. And it's also drag. So I could throw this javelin through the air like this, or I could throw it through the air like this. The new chip allows me to track all of that data and Bluetooth back to my phone. The problem that we had, though, is what about Bluetooth limitations? After about 10 meters away, it disconnects from my phone. It no longer knows. It no longer knows what it's doing. And if I'm having release velocities of 30 meters per second, that means I'm tracking this javelin for a third of a second. Not nearly long enough for what we wanted. And that's when we came up with the idea of having an internal storage onto the device so that I go and throw, and I walk over, pick up that javelin, and it finally gets back to my phone, and all of that data is transferred to my phone. And best yet, there's a micro USB on here. I can take this home with me at the end of the day, have 100 throws, all back up, export to my computer. I can actually track my progress over time, over the week, over the month, and over the entire year. Not just one meet anymore, not just 6 throws, but the entire year of practicing. And this is what's going to give me the upper hand on my competition and help Team USA win more medals. But this isn't just for track and field. The sensor kit can be used for so many different sports, and that's why I'm going to bring Max on over here and talk to you more about it.
Yeah, thanks.
No problem.
So we divide sports into a few categories. There is a fully observable sport. If you think of a javelin, right? You could stand in front of a person and begin to understand exactly how they threw. You can take a picture of them throwing. You can take a video, slow it down. You can have a very good understanding, and then begin, of course, to measure, right? So you can have a very good understanding how how an athlete is performing. And then there are sports that are really not observable with ease. One of those sports is skiing, actually. And so, as part of the work that we did with Cyrus, we actually did work on instrumenting the human body. So the new IoT, the thing that we think about as Internet of Things, is actually human body becomes the device. So if you begin to instrument an athlete, and you begin to understand the deviation of what's called a professional athlete or a professional person performing a skill versus a non-professional performing a skill, you can definitely tell the difference. So skiing is one of those unforgivable sports. You make a mistake, you go tumble down the mountain. If you've ever tried to ski and you've ever tried to compare yourself, unless you're an Olympic skier, against an Olympic skier, your position and your body position is actually very different. And so the one thing we're going to show you is a professional skier versus a non-professional skier. So I'm going to switch to monitor 7, and we're going to run the video. And what you see here, and this is all for science. So what you see on the right is a skier skiing down the mountain. What you see on the left, if you notice the arms, you see the erratic movement of the upper body. And that's actually not noticeable on the video. So the moment you do an isolation and you're able to see the video in full detail, you're able to tell both from sensors and from using computer vision on specifically who is professional, who's not. So pausing that video for a moment and playing this video, I want you to look at the model and look at the video, and you can actually tell the difference, right? So the bottom one is an Alpine 8 bronze medalist, and the top is myself. So I had to sacrifice myself for your enjoyment. And so the moment we begin to pull all this together using machine learning, we were actually able to identify 2,700 specific data attributes to attribute and be able to detect. So imagine all that was done using these little homemade sensors. And so what we hope to do is to take this really to the next level, right, and be able to allow a high school team, your local racing team, your high school track and field team to be able to get players to perform better, but yet also stay safe. And to put everything together, everything we discussed around sensors and around the SDK, I'm going to invite Kevin back on the stage, and he'll give you all the details.
Thanks, Max. This is great. All right, I'm going to switch to the screen that has Max still skiing, I think. Or is it Nick? So the important thing about sensors is that it was hard to imagine how to put these devices on some of the equipment that we had to deal with. So for instance, the skis are, they're a natural place for a sensor, really, but you have to figure out how to place it there, how to attach the sensor on skis. And besides this being pretty, of course, it also gathers all the orientation data from skiing, something that the professionals need in order to understand what works and what doesn't. So I'm going to go to our GitHub repo just to show you guys again what is it that we're building. So this is the repo itself, and there is a quick start on how to literally take everything we built and plug it into your app. So right now it's a UWP app, but we are making it Xamarin enabled. There is nothing that prevents it from not being used in iOS and Android. And so this entire SDK is for your enjoyment to use and to use in the apps if you want to use sensors. So the sensors that we currently support, literally, all you need to do is, if you want to add your own sensor, or if you have a manufacturer that has sensors, is to add a sensor to a class we call a sensor registry. And it's it's a basic class that basically describes capabilities of each device. And I'm going to show you just on the example of this phone device here, how I can connect to sensors that are, I believe, so one of these guys is on the Javelin that Cyrus has. So let's see if we can capture some of the output from this sensor. You won't be able to see the actual screen display from here, but I'm just going to show you the data as it comes from the sensor. So as you can see at the bottom, so what I need to do is just to subscribe to a sensor, and then that sensor starts sending me the data automatically. And what data you expect from the sensor is actually determined by the sensor itself. So it can be a very, very high frequency stuff, like 100 hertz, for instance, or it can be maybe 1,000 hertz. So it's all possible because the latest Bluetooth stack gives us several advantages in the Creator Update. First of all, it gives us an ability to connect to connected devices without pairing with them. So you don't need to use things like pairing. You can simply use a GET service and discover a device and then bring the data directly from the device as long as you can see the device. So one of the things that Cyrus mentioned was the ability to actually store the data on the device sometimes. And that is helpful because, Cyrus throws the javelin, and I don't know, is it like maybe 80 meters? Oh, okay, 80 meters. Okay, 80 meters to maybe 90 meters, right? And this is an Olympic throw. And that is already beyond the Bluetooth capabilities as we know them today. So in order for us to capture this data, we managed to create a synchronization framework that actually stores the data for just the throw that Cyrus does on the sensor, and then reconnects and resynchronizes the data back with Azure when the connection is available. So essentially, it's all for you guys to use. The sensor kit itself, and I can show you some of the source code here. It's pretty simple. We just started working on this stuff, really. But the advantages that it provides, and I'll show you some of the sensor kit connector class. So let's say if you have a device manufacturer that makes something for, I don't know, some kind of a sensor that has a Bluetooth connectivity. All you need to do is just to clone the sensor kit connector class, and literally you are connected. You have the benefit and advantage of having all this data right into your app directly. So again, the framework is still evolving. It is probably going to be part of maybe the IoT hub. Maybe we'll use it for. Maybe we'll integrate some additional things like Wi-Fi into that. But the benefits we already see is that we can build things for Olympic athletes, and these things are really at the top edge of innovation today. So I'm gonna stop here and just go back for a second to the presentation that Max was showing you guys. So back to skiing, so to speak. So again, this is the sensor kit. This is what it does. Really providing connectivity, uploading data to Azure. But then we also have, as part of the sensor kit, we have R scripts and machine learning tools that really help you understand what is happening with the orientation data or what is happening with the location data. So for instance, this feature engineering script that the machine learning team put together, and we have an additional session on that if you guys want to dive into this and see what happens here. So this is where the detection of 2,700 skiing-specific features is happening. This is where we're able to actually tell a good skier or an Olympic level skier from an intermediate skier, like Max, for example, right? So this is actually giving us a tool to look into high frequency data that many apps today simply ignore. So we don't see this data being uploaded from the GPS tracking apps. They simply limit themselves to maybe 20 meters frequency. Whereas in this case, we're looking at 100 hertz data, and that data is processed in Azure by the machine learning models, and we're able to get some very meaningful results out of this. So I hope you guys will take a look. I hope you'll build your own sensors. I hope you will be helping maybe your local school, maybe your local sports team with this. But this definitely gives us an additional point to get started with the machine learning technology, and also with some of the advanced things that we currently have in the Windows Bluetooth stack. So definitely, I'll be happy to answer any questions after this. Go to our GitHub repo, check our tech code story. I think that's what it's called, and also check the virtual keynote by John Shuchak, and and goes about how the sports study, how it started and how we were able to get to these results. To me, it's very surprising because the precision, and we were actually able to get to 96% probability of telling, for instance, a good athlete from an average athlete. And if you think about that, just in terms of how much data you typically need to analyze to get to these results, how much biomechanics, how much kinematics work you need to do, you realize that machine learning gives us this additional edge, this ability that may allow Cyrus to actually win his next Olympic medal. So let's just wish Cyrus all the best in his Olympic trials. And thank you, Cyrus, so much for attending this event. Thank you. And thanks for your innovation, too. Thank you, guys.